Sharpshot21 here, and we are back on the Voron build today. Excuse me. Today we are starting on the wiring. So I'm hopefully going to fit it all in one video. It might end up being two. We'll see. Might just be a long one. There isn't too much to it. We do have to be a little bit careful because we are working with both mains voltage, 24 volts, and 5 volts. Now I'm going to do a couple of things the manual doesn't tell you to do, a couple of things it does tell you to do, and a couple of things that I'm just going to do my way. And I have my reasons, and I'll go through them when I get there. But let's get started. Okay, so I guess this didn't record. But I've got the limit switches for the little printer, the Voron V0. I'm only going to be using one of these on the V2.4. But when wiring these up, we've got 3 terminals across the bottom. This one is common. This one is normally closed. The center one is normally open. The way the firmware is set up for the Voron V0 and the Voron 2.4 is common and closed. Normally closed are the limits, the connections you need. Now for the V0 we need 3 of these. 2 of them are static. One of them moves on the gantry. The 2 static ones I'm putting about 3 feet of wire on. I'd rather have too much and trim it than not enough. The one on the gantry I'm putting about 6 feet of wire on. Again, same thing. I've already got the wire measured out. I'm using white and yellow silicon wire. The white will be the common. The yellow will be to the normally closed leg. So let me get the ends trimmed off here. And get the wire stripped. Won't take much. Just a little bit. Couple millimeters, I don't know, 3/16 of an inch. I'm not going to do anything with the ends. But I am going to try to sneak the wire through. The little tiny hole in the legs. I'm going to try to sneak the wire through that and solder it that way. I run my soldering iron nice and hot, about 700. I am using leaded solder for this. What you use is your preference. I like how the leaded solder works, and it's what I have on hand. I'll come back when I've got these all done, but that's kind of what you're looking for. We will be putting some heat shrink on. This is marine heat shrink, so it's sealed. Not that that's a prop or a factor with this, but that is something that I just buy marine and I use it on everything. I'll be back when I'm all done. Alright. So I did mention I'm using this guy. Now, I've got it set up like this. So when it mounts, it'll mount like this. Plug will be at the bottom, switch will be at the top. Just my preference. You can mount it however you want. I have drilled a couple of holes in this back plate here. As I said, I'm going to modify this back plate when I print the new version. So this one's going to be for the power cord coming in. That one's going to be for the tool head. That one's going to be for all of the lower, the AB motors, the extruder motor, the Z motor, the end stops, all that stuff is going to come through this hole, maybe this hole. I'm going to try to reserve this just for the tool head. Got the buck converter here, 24 volts in, 5 volts out, SKR Mini, our Cridom SSR, and our Meanwell LRS 100-100-24. So this is our main DC, AC to DC power brick. As I've mentioned, I am going to put a thermal fuse on the bed when I do get around to actually mounting, or when I do the rebuild on this. I have them. I'm just not going to use it right now because the bed's mounted. I don't feel like taking it apart. I am going to sacrifice a power cord because I've already sacrificed the end of this. So this is going to be our cord going from our power panel, which will be over here, to our line, neutral, and ground on the power brick. Once those are connected, and before we connect anything else up to the 24 volt supply, we're going to check the 24 volt supply on this. Anything that's tying into this or this is going to get spade terminals or ring terminals, depending on what it is. Anything coming off of this is probably going to get a ring terminal, and then I'm going to use DuPonts to connect it to the Raspberry Pi. I'm going to tie right into the GPIO. I don't have a USB-C I want to tear apart, nor do I want to get one, because on the final design, as I've said, the extruder tends to mount right about here, and oh gee, what do you know, that's right in the way. No biggie, just need to make some concessions, and I prefer to run it into the GPIO anyways. You're going to need, as I said, some ring terminals and some spade terminals. You're also going to need some JSTs. I've got a knockoff kit. Amazon. I think I paid $15 for it. For temporary stuff for the motor mounts, at least for the AB, the Z and probably the extruder have enough tail on them to reach where they need to mount and be trimmed correctly. So I'm going to tie right into those. The A and B drives don't. So I'm going to use DuPonts for now. I've got Molexes coming. They'll go on with the rebuild. I think that's kind of it. Other tools that will be handy to have: a multimeter of some sort, nips, and a set of auto strippers, or just whatever strippers you like. These also have a nice big wire cutter in them, but I like using these flush cutters, nippers, whatever you want to call them. But this is handy. We're also going to need, obviously, some wire. I've got this Taofeng kit, which we've already used some for the end stops, but it's got the blue, red, green, and black, same colors as are the motors. So we can make up some extension leads for the A and B drive, and maybe even the extruder drive. I might trim the extruder down to something like this, but I think I can reach, so I'm not gonna. If I got to, I will, and I'll just solder these. I put the order in on Digi. It's already coming. No sense to add another one and pay for shipping again. So I think we are going to start with getting this soldered together, because I am going to solder this. I was going to put terminals on. I'm like, I'm going to use this one. It's going to be the same one. I'm going to use this. It's going to be the same one. In fact, I'm just going to strip it a little bit. Strip them off, solder it, heat shrink it, run enough cable so I can strip it back, strip the wires, and put ring terminals on, or spades, I'm not sure which, and tie it in. I don't feel like running individual wires over here. I want to run a cable. From here, I'll run individual wires. We will want to also have the wiring diagram, because from the line we tie into this terminal and then out to one of the bed leads, and the other bed lead comes back in and ties into the neutral. The thermistor wires go right onto a JST connector. We got 24 volts out into 24 volts there, and 24 volts out into 24 volts there. We have a little bit of work to do, but I'm going to pull up a diagram for I think that's a C15. There's a C13 and a C15, and I can never remember which is which. Okay, so these have what is a C13. A C15 will have a notch. So right above my thumbnail, a C13 will have a notch, or a C15 will have a notch. These don't, so they're C13s. So I need to pull up a wiring diagram so I can then make the correct connections to the back here. Obviously this one is going to be, this top one will be the ground. I'm not sure if that's neutral or if that's neutral. That's what the multimeter is for. So let me grab a chair and we'll get started with that. Okay, so your standard C13 has your ground up here, your neutral over here, your hot over here. Oh, excuse me. Your standard C13 has your ground up here, your neutral over here, your hot over here. Incidentally, The ground on this plug is up here. Your neutral is over here. And your hot, or your line, is over here. Now, since I'm going to be pulling apart one of these, I went and probed it. This has 3 wires in it. Let me peel the insulation back and I'll show you what I got. You might also want a knife for doing this. You just want to pull off the sheathing. You don't want to pull off the, you don't want to nick the insulators inside the wire. Now this is fairly common color code depending on where you are in the world, but this reddish brown one is hot, this bluish one is neutral, and the yellow with the green stripe is ground. So I'm going to strip these back, toss some heat shrink on, change out my soldering iron tip, and we'll get it soldered up to here. Okay, so got that soldered. Remember, yellow with the green stripe is ground, blue is neutral, red is hot or line. I'm going to mount this up temporarily, and we'll measure out the length of the cable we need. So I'll be back when that's done. Alright, so mounted the box, run the wire up through the hole, and run it over. Now, I'm leaving it a little long this time, just because I have a sneaky suspicion I'm going to have to cut off whatever terminals I crimp on when I go to disassemble this whole thing for reassembly. I'm going to try not to, but I think I'm going to have to. And I think I want to use ring terminals for this and spade terminals for the bed. And so I'm going to use I'm going to grab my screwdriver because I finally found it. Got one of these multi-kits. Super handy. This is where tweezers are handy, because you can then go in and grab the terminal if it falls over. I think I can get away with, no, I can't get away with the narrows. So I've got 2 styles, narrow and a wide. I've got a wide, and that fits over the terminal, and it fits in the hole. Actually, I've got 3. I've got narrows, wides, and extra wides. So these are the middle. Also got the same thing with the rings. Actually, no. With the rings, I've just got narrows and wides. And it looks like the wides are the way to go. So let me get this trimmed off, pulled down, insulation pulled off, and then we'll break out the crimpers. Now for these terminals, you don't need a whole lot of wire. probably only about 1/8 of an inch, or about 3 mil, 4 mil, somewhere in there. Okay, so got to tighten down, or strip down. I'm going to trim these even, strip them off. Now I've left a lot of tail on these for a couple reasons. The main one is I have a sneaking suspicion I'm going to have to cut these crimps off when I go to do the final assembly. Just because I don't think I'll be able to fit them back through the hole. So snip them off, still have enough tail to put new crimps on when I'm done. You only need about 1/8 of an inch or 3.5 mil of wire for these crimps. I think, yes, the red crimps are the ones we want. Now these crimpers have 3 different sizes, the reds, the blues, and the yellows. That's pretty much universal. Crimp these on, make sure it crimps nice and tight. Now, we'll get these terminals mounted. Plug this thing in, check the voltage. So, give me a second to screw these down and find the proper cord for this. Okay, we are plugged in. Plumbed in. Remove any extraneous wires that could get in this for the moment. Find your multimeter, because you are a smart person, and set it down somewhere. Set it for DC. Check that you're 0. Flip the switch. Okay, no sparks. And the little green light, so we're doing good. We're gonna go between 2 terminals here. And we are at 24.19 volts. There's an adjustment screw here. And I need a different head. Okay, so we're going to adjust this to 24. 24.07, close enough. We'll turn this back off. I just want to see how long this takes to discharge, because unplug it. Because there's some pretty honking capacitors in this thing. And I don't want to start messing around until it's out. So I'm going to keep the multimeter on and just keep an eye on the voltage. This will drain down faster when stuff is powered on and actually drawing from it. Right now we're just dealing with the capacitor RC time constant. But you don't want to start connecting things up until it's totally off and you unplug this side. If you don't unplug the mains, you're going to have an exciting time if you bump this switch. So just be safe and unplug it. Now we're down to 2 volts. That's good enough, and it's going to continually drop from there. Now we're done with the soldering, and what should be the any multimeter use at this point. So, next step is we're going to take, we've got a big spool of this stuff, and it is 20 gauge wire. And it is 20 gauge twin pair. Now it's not pull apart wire though. It's okay. So get this twin lead. And I'm going to crimp on 2 spade ends. I'm going to go from V plus and V minus into, so we're going to go from V minus and V plus into this set of terminals. And then I'm going to cut a second set and go into this set of terminals, both coming off of this. There are 2 sets of plugs on each, so we're going to do that. The ones going into the SKR Mini are going to get ferrules crimped on. The ones going into the buck converter are going to get some more spades. Now I'm cutting all of these long just to ensure that I have enough. I'd rather cut the wire long and have to trim it down than it would cut it short and have to cut more wire off the spool. Now we're going to follow standard convention here. Black will be negative, red will be positive. The left, if you're looking at the terminal strip, the left set will go to the SKR, the right set will go to the buck converter. I'm trying to make everything wiring-wise as modular as possible. That way, if a component does break, we can replace it. These wires I can trim pretty much to length, as I don't foresee them ever coming out. These are pretty much at length. Now, these are getting a different type of crimp connector. There are these. Quite handy little crimps. They come in various sizes. You do need a special tool for them, but they are the proper method of putting a wire like this into a terminal block. I have a screw down squish type terminal block. So what you do is, again, you try to tidy up the strands as nice as you can. And I think these are going to be blacks. I don't think they're going to be reds. No, they were going to be reds. So, you slide it on, take your crimper, slide it down as much as possible, crimp it, crimps on. Now I'm going to take my small Phillips head, or flathead, make sure that's backed out all the way. Open the crimp housing all the way, and then snug it down. Repeat as necessary. I'll be back when I've got the wires run into the buck converter as well. You've seen me do this. Okay, I don't know if this started or not, but I've got the two spade crimps done for the power to the pie. I'm powering the pie by the GPIO headers, so I need to put a couple of DuPont connectors on, or DuPont clones. I've already crimped this one. Now, there is a risk for powering it this way, because the GPIO header isn't fused. It's not a problem, or rather, it could be a problem, but I'm willing to take the risk. Alright, I need to crimp this just a little tighter. Now, that's one crimp on. You don't need, I don't know if you can be able to see this, but I've got about 3 mil of wire. That's too much. So I'm going to trim off about 1 mil. And then it appears that the correct crimper on this one is the 1.6. Just go easy with it. You don't need to gorilla these things. I mean, you want it tight, but you don't want it Hulk smash. I got a little bit of insulation that's being a problem here. So I'm just going to trim that off. These connectors can be a little fiddly. But once they're in, they're in. So let me get this plugged in. I got to find a couple of pins, and then we will start on the motor connections. Okay, so the pin furthest away from the Ethernet and USB ports on the outside is 5 volts. The fourth pin up away on the outside from the USB and Ethernet is ground. So that's where I've got those two tied in. Next step, at least the next one I'd like to take, so I can get done with the heavy crimping, is the bed power. Now, one of these I'm going to just tie right into the neutral. One of these has to go over to the SSR, and then the SSR gets tied into the line. I'm also going to put the thermal fuse on one of these later. It doesn't really matter which one I put it on because the thermal fuses have nice big tails. So I'm going to cut these to length and trim them a little bit afterwards. So I only have to use up one extra spade connector. So we'll get the spade connectors back out. Now this wire is kind of nasty stuff because it has a fiberglass braid around it, so it doesn't always strip nice. Yeah, see, doesn't strip. So take your side cutters, flush cutters, nippers, and you just carefully work around it. And you will eventually get your fingertip full of the fibers, which feels phenomenal for a couple days. Which will also pull off what you want. And I think I can get away with reds for this one as well. Yes, so we're going to go with the reds for this as well. Now, this one goes to the neutral. This other one goes over to the SSR. And according to the wiring diagram for the SSR, the bottom I don't know if you'll be able to see it, but there's two pins on the SSR that run parallel to the short axis. The bottom one gets the lead that goes to the bed. The top one gets the lead coming from the line connection. So, I'm going to use a bunch. Again, so they're modular. A bunch of these, I don't know what they're called, like connectors, spade connectors versus, or disconnect. I guess they're called disconnects. Now they're a little big for these terminals, but they will fit perfectly. They will fit well enough. I'm also going to use some heat shrink to insulate these, just as some extra protection. Okay. grab my heat shrink. Oh, I had a piece out still, but I guess not. Oh, no, there it is. Okay, gotta go one size up, so it doesn't matter. Now, again, I'm doing this just as an extra safety precaution. If you guys had insulated terminals like this, you wouldn't need to do this. But we are dealing with 120 volts, or if you're in not the US, 240 volts. So, caution is warranted. I wanted to run that under. Now, I'm going to use one of the leftover lengths here to make the jumper from the line to the line. Got the SSR powered, or the power connections on the SSR made. Now, this is the SSR positive control. This is the negative control. SSR control comes off of the PT-DET header on the SKR Mini. The positive pin is the one nearest to the 2-pin header. The negative pin is the one in the middle. This is a JST with a 3-pin. I want to grab a couple of lengths of wire. We're going to run yellow for the positive, white for the negative, and we'll make this up. Fairly straightforward. You've seen me do these crimps. You've seen me do the JST crimps, the same as the DuPonts. Give me a couple minutes, I'll get that one in there. Alright, so the thermistor for the bed is done. I've got the Z and the Y end stop wires. Those we will do next. Again, it is another 2 of these little tiny 2-pin, we got the Z and the Y end stops. It is another 2 of these little teeny tiny 2-pin JST connectors. We're getting near the end of the JSTs. We only have, after those two more. One for the X and one for the odd end thermistor. Those I can't do just yet because I'm still waiting on that rail. I will include them in this video once I get the rail. So my comments might be a little incongruous, but it's because the first half of this video will be pre-rail, the second half will be post-rail. I might even just break the tool head off into its own. So, let me get those wired up, and then I will come back and give you a quick walkthrough, and we'll start on the DuPont wiring for the A and B drive. Okay, so X and Y Z stops are done, or N stops are done. Now, this is the Z motor. We're going to do that one next. And then I'll make up the tails for the A and the B drive, because that's going to be kind of boring. Now, there's a very specific wiring order for these, and I think I've got it figured out. It should be blue, red, green, black. As read from, if you're looking at the board like this, the pin furthest on the left should be blue, furthest on the right should be black. Should be. If it's not, and things go wonky, unpin the connector and switch pairs. Might take a little bit of doing, but you'll find them. So, let me get this trimmed down, pigtail made up. Again, I'm going to leave this a little long, that way I can just snip it off, reuse the connector housing, crimp new ends on it for the next one. Though I think I might just put a slot here for all the cables for the next one, so I might just cut them out. We'll see what I do. Okay, so I've got the tails, or the extensions for the A and B motors wired in. I'm just trying to figure out where I want to mount the tails. I've already trimmed these, because when I redo this, I'm going to turn these motors 90. So they come out of the motor here. So one motor, I'll put a connector here. This motor is going to get a connector kind of down here. Let me wire up the DuPonts, and I'll come back with those. Okay, so got the B and the A drive with the DuPonts. This one's hidden back here. But with the DuPonts wired up, I'll probably wrap them in electrical tape just to hold them together for the initial print. Now, the last thing we need to do is wire in this guy. This is the pocket watch extruder. So I'm thinking I want it to be about here. Now that way, the out port is up on top and somewhat in the middle. So it's gonna live about here probably. So that's about where I want it. We got plenty of wire. So I'm just gonna put a JST on this thing and call it good. Okay, so I've kind of got the pocket watch mounted with VHB tape. Wires running down through here. It's plumbed in. Only thing left to do, which will be another video, is the tool head wiring. So, Shot21, and I appreciate you tuning in for this. I hope to see you guys next time. If you found this helpful, informative, if you got comments, let me know. Leave them down below, and I hope to see you next time. If you did like this, hit the like button and subscribe. And well, thanks for watching this Voron build so far. We're almost done. We're getting close. As always, Sharps out.
Thank you all for watching. I hope you enjoyed. If you did, please hit the like and subscribe buttons. It really helps me out, and it lets you know when I put something new up. New videos will be going up on Tuesdays or Thursdays at 8 a.m. Eastern. And if I do decide to do live streams, I will try to give 24 hours notice. So hit the subscribe button on the channel, and you'll be notified when I post that stuff too. Hope to see you next time. Sharps out.